your performance finals. I know that you just took it yesterday. If you missed it for whatever reason, you need to come see me after school on Tuesdays and Thursdays, or you can see me during advisement. Up to you. Please don't ask me to give it to you during class. We don't have enough time for that. We have to get through 2 more units before the end of the semester. We got lots to do. Okay, so Noah will select 1 card at random from a standard deck of cards. How many cards are in a deck? Okay, so really quick, for those of you who have never played with cards before, okay, there's an ace in each suit. There are 4 different suits. There are 2, 3, 4, 5, 6, 7, 8, 9, 10, and then there are jacks, queens, and kings. Okay, there are 52 in a deck. Okay, so come back over here. What is the probability that the card is going to be a queen? So looking at our deck, how many queens do we have? 4. All right, so we're gonna have 4 out of how many cards do we have in total? Okay, so normally when we're dealing with cards, we're gonna do this in the smallest fraction. Okay, so this will be 1 out of 13. Or if you want this in percent form, 1 divided by 13, I think is like 7%, but I might be making that up. Nope, that's right. 8%. Okay. What is the probability that the card is a heart? Now, how many hearts do we have from our deck of cards? Look at it again. How many hearts? We have 13. Okay. So we've got 13 out of 52. Okay. So when we simplify that, that's 1/4, which is 25%. Okay. The probability that the card is a queen and a heart, how many hearts do I have that are queens? 1 heart that is a queen. Okay. Out of how many cards in total? 52. If I take 1 divided by 52, that's going to give me 2%. Okay. If Elena pulls out only the hearts from the from the deck, and sets the rest of the cards aside, she shuffles the hearts and draws 1 card. What's the probability she gets a queen? So out of the 13 that she pulled out from the deck, what's her probability that she gets a queen? 1 out of 13, which is 8%. Okay, so just a refresher, so just a refresher for people who don't normally play with cards, aces can normally be counted as 1, or in some games it's counted as an 11, just as a heads up. It depends on the game that you're playing, okay? For instance, blackjack or 21, as some people call it. Yeah, you can play it either way. Or the jack counts as an 11, the queen counts as a 12, and this counts as a 13. So it just depends on the game that you're playing. But this is the order that they go in. We got diamonds, clovers, yeah, hearts, and then spades. These are also called clubs in some games, okay? Really quick, look at the scenario below. What do you notice about the numerator and the denominator of the probabilities that could help create a formula? A class of 40 students was asked the question, do you like school? Wow. Okay, the results are recorded on a 2-way table. So what I would do is I would go ahead and write down one of these tables, because this is the same, and then go ahead and write down these 2 formulas. Okay, so really quick. Okay, so on here, we have the probability, okay, of yes given male. So that means that we have the probability of both. That means that they're yes and male out of the probability of them being a male. Does that make sense? Okay, so it's both over whatever you're looking at, which is the given, okay? On this next one, the probability of female and no. out of all the people who said no. Okay. So that's how they're getting that. Okay. So conditional probability means that if you are looking for a conditional probability of A given B, the numerator should always be, it's right here. Ooh, nope. There we go. A and B. And then the denominator should be B or what is given. Okay, so the formula for this is probability of A intersection of B over the probability of B. Okay, so we talked about this last time. Intersection means where they cross. Okay, so where they cross over either on that two-way table or within the probability. Okay. So, okay. Okay, so we're gonna discuss. We're gonna go back. Ready? Are you 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 ready? Okay. No. Okay. So toilet paper preference. Back to this whole discussion. Under or over? Under is champion. Okay. So we have a two-way table, right? We've got the probability of male given under, right? So we're gonna find the probabilities below to test the formula. Okay, so ready? You gotta pay attention, otherwise you're gonna miss this. Okay, so what is the probability of male and that it's under? So we got 4 out of 21. So we plug in 4 divided by 21 into our calculator. We're gonna get 0.19. If we got the probability of under, okay, so out of all of these people, we had 12 out of 21, right? With me so far? Okay, so that's 0.57. Now, we want to find the probability of male given that it's under, okay? So that means that I'm going to take this 0.19 and divide it by 0.57, right? If I take 0.19 and divide it by 0.57, I get 33%. With me? Yep. So if I did what I've taught you, right, where you have male given that it's under, so out of the under, how many people were male? That would be 4 out of 12, right? Which is what? 33%. Notice how this number and this number are the same. Okay, so the reason why is because when you actually write out this formula, you're saying probability of A intersection of B over probability of B. So we're saying the probability of male and under given the probability of under. This is the same thing as what we did shorthanded, which was this. I taught you this first. I taught you shorthand first. Okay, take a sec. So only with the formula. So we got, okay, so Mary examined a random sample of deodorants distributed by her company. She found the following probabilities. The probability of men, 55%. The probability of botanic scents, 18%. Probability of men and botanic, 5%. Okay, so find the probability that a deodorant is given for men, given that it has a botanic scent. So the way we're going to do this is, 1, write these 3 things down. And I want you to write this statement out. Okay. Take a second, you're writing it down. Have the probability of men, that a deodorant is for men, given that it has a botanic scent. So the way we're going to do this is we're going to say the probability of men and the botanic over the probability of it being botanic. Okay, so the way I'm going to do this is I'm going to say 0.05 divided by 0.18. So 0.05 divided by 0.18 is going to give me about 28%. Okay. No, we didn't use this probability of min though. Okay, it's just kind of chilling there too. Okay, so looking at this problem, there's a lot of information that they're telling you. Okay, so it says determine the probability that a high school senior will rent a limo given that the high school senior is going to prom. So that is probability of being prom and limo, right? And the probability that they are going to prom, so a senior, right? Going to prom. So this is going to be 0.57 out of 0.85. When you do that, that's going to be 67%, which is what? Valencia. Yay! Okay, first of all. Okay. Easy. I'm going to let her know you said that. Okay. A pharmaceutical company is testing a new medicine for a disease using 115 test subjects. Some of the test subjects are given the new medicine and others are given a placebo. Do y'all know what a placebo is? Yes. Go ahead.
A placebo is like
He doesn't know.
yes I do. It's a fake.
It's a fake.
I read.
Yeah. I hear you. Go ahead.
It's fine.
Okay. All right. I know. All right. So, what could a probability that the scientists might be interested in knowing? So looking at this data, what would you kind of be interested in knowing about? If they were,
If they had no symptoms,
if they had no symptoms but
given medicine.
given medicine, okay, and then maybe they would want to see why.
Yeah, but I'll get it.
Okay, so maybe given the placebo, but the symptoms persist. Maybe no symptoms and still given placebo. Okay, all the information is very important. Okay. Go ahead and take a moment, read this problem over, okay, and see if you can figure it out. Okay, so it says suppose 80% of the students in Gwinnett County have a TikTok account, and TikTok account. All right, and 60% of the students have a Snapchat account. Of those students, 45% have both. What is the probability that a student has a Snapchat account given that they have a TikTok account? So what you're going to do is you're going to say probability of both over the probability that they have a TikTok account. Okay, so that's going to be 0.45 divided by 0.80, which is 56. Is that what y'all got? Okay. 56.25%. Okay, yes. So it's the probability that they have Snap and TikTok. Given that they have TikTok. Huh?
No.
But we're assuming that they do have TikTok too. Because we're looking at when they have TikTok and they have Snapchat. Yeah. Let's look at the next one. Okay. Okay. Go ahead and take a look at the problem on the board.